Is the PowerPoint presentation on my screen visible? Okay, very good. So now today we will be studying about those signed binary numbers, as yesterday we were looking, and then ones and twos complements we already have discussed. I think I had given you this number minus 17 to the base 10 to be represented in sign magnitude, ones complement and twos complement. Can you let me know what was the sign magnitude representation of minus 17? Yes, please type your answer in the chat box. Okay, this is 111001 for most of you. Correct? So the sign magnitude representation. Okay, so sign magnitude representation for plus 17 should be what? It should be, just a minute. Yeah, it should be this, correct? 010001. You can get a quick conversion of this. So this is 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3, 2 raised to the power 4, which is 16, plus this is 1, 17. So what will be this number in sign magnitude? You just have to reserve the most significant bit to 1 or change it to 1. So this is the sign magnitude representation for minus 17. So most of you have done it correctly. Those who missed it, please note this logic, or if you have a question, please feel free to ask. Then second was ones complement. So okay, I mean, rather than asking you, I just showed it on the screen. So this should be the ones complement. Is this what everyone have got? Ones complement representation for minus 17. Okay, ones complement. Nishant is saying 01110. Yes, that's what it is. 01110. So what is two's complement representation for minus 17? Two's complement is 101111, right? Okay, let us see what it is. So this is your two's complement representation. So having done this, I am sure all of you are comfortable now with how to represent negative numbers in either ones complement or two's complement or in what you call sign magnitude representation. Fine. Let us come to one more uh, example now. Yesterday, there were queries regarding how we can represent the fractional numbers. So now we will be seeing few examples which will be actually representing fractional numbers. Plus, okay, there was one more query from one student who had sent me the pictures of some two books, and she was asking that the two books are representing the one's complement and two's complement in different way. Who was the student? I didn't have her name or his name. I'm not sure. Who asked this question? Tanvi. Very good, Tanvi. So if I could see that carefully, there was nothing very different actually. In one of the book, the number of bits was 4. In other book, the number of bits was 5, I think. Is it 5? 1, 2, 3, 4, 5. 5. So there is, I mean, no problem as such in this, because it is just what bit size you are using. That is also known as word size. Means how many bits per number you are using. It is just about that. So for example, you may have to represent, say, 1, simple 1 in binary. If you have a 4-bit word, then you will be representing that with 0001, isn't it? So 1, let me type it in your chat box. In 4-bit binary system would be 0001, correct? The same in 8-bit binary system would be 0, 0, 0, 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, 1. That should be the same number in what you call 8-bit number system, or if the word size is 8-bit, then it should be like that. If you will notice the uh, last 4 digits, or the 4 bits towards the rightmost portion of the number, that they will be like exactly the same way. So there is no technical difference in that. Is that clear, Tanvi? If you note those tables carefully, you should see that yes, the numbers are exactly same, except for one additional bit sitting in the leftmost of the number. Is that clear, Tanvi? Okay, go back and try to see both books. They will be exactly the same if you are not having that right now with you. Okay. Now, okay, let's come to those fractional numbers. How to represent negative binary numbers. Uh, Before I talk about that, have anyone done this? Have anyone tried this by their own self? How to represent fractional binary numbers? Did anyone try that? Yes or no? I mean, if anyone has tried, please just type yes. And if somebody didn't try, nobody tried, then write down no. No one tried it. Okay, fine. Now, okay, Parikshit is trying something. This. What is the logic? I don't know, but okay, I will explain it rather than wasting time in asking questions, so that you could understand what it is and how it is represented. Okay, meanwhile, I request you to mark your attendance as well. Type your roll numbers in the chat box, and that's all for your attendance. Fine. Now, how to represent this? Well, if we look at, let us first look at the positive part of this number. If we see the positive counterpart of this number, that is going to be 12.5, right? And in that positive part, the integer part is 12, which in binary number looks like this: 0, 1, 1, 0, 0. I hope you are comfortable now with this simple conversion. Similarly, how would the 0.5 look like? It would look like this: 0.1000, right? You can place any zero if there is no problem in that. Now, what should be 12.5, by the way? Let us first talk of the positive number. So 12.5 would be just simple this one, right? 0100.1. Correct? Now, uh, the question is how to represent minus 12.5. Now, the question here is that, okay, let us suppose we want to represent minus 12.5 in 2's complement. And I will be restricting myself to the 2's complement because uh, practically in most digital circuits, the 2's complement representation is one of the most friendly representation. Why so? This we will be understanding in coming lectures, not today itself. So let us stick to the 2's complement. So, okay, now question is, the 2's complement of this number is going to be minus 12.5 as such by the definition. But the question is how to find out 2's complement of this number. Should we add, okay, should we take 1's complement of only integer part, or should we take 1's complement of everything and then add 1 to that, or how to get it done? Before we go to that, let us try to understand minus 12.5 this way. We can write down minus 12.5 like this. I mean, something like minus 13 plus 0.5, isn't it? So now let us try to go to say minus 13. How to represent minus 13? So for minus 13, we have to first represent 13, then have to take 2's complement of it, correct? So this is your 13. If this number is 12, if you add 1 to it, that will be 13. That's what it is, correct? So minus 13 if you write down in 2's complement representation, this will be what's complement of it, and then added 1 to it. Or if you follow the yesterday's rule, so if the least significant bit is 1, keep it as such, and then invert everything else. So this is 1, this 0 became 1, these two ones became two zeros, and this became 1. So this is what is minus 13. Well, so what is minus 12.5 is this. So how to represent that in 2's complement representation is like, okay, minus 13, this part is minus 13, isn't it? And 0.5 is written as such. So what is 0.5? This is your 0.5, right? So I would write it as such exactly this way. So this is your minus 12.5. Uh, Before I move to the next case, is this clear first? Okay, let me ask. Is this part clear? How I did this? Okay, fine, very good. Now you will say, I mean, why did I choose minus 12.5 to be say minus 13 plus uh, 0.5? Why not some other thing? Like, okay, I should have chosen minus 14 plus 1.5 or something else. So the basic thing is that I have to first look to the uh, integer next to it. So it is minus 12. Then there will be something like, what will be the next integer? Minus 13. So that is first thing, and then we have to take care of uh, the fractional part. So then accordingly, what has to be subtracted, we can do it that way. But that is also not the mandatory thing. We can understand, or we can think of minus 12.5 as minus 25 divided by 2, isn't it? That's equally well. Minus 12.5 is minus 25 divided by 2. Now let us first try to write down minus 25 in 2's complement. For that, we will first need 25. And what is 25? I'm sure this is the number, you can get it. And then what will be minus 25? Or let us say minus 25.0. You have to take 2's complement of it. So you take 2's complement of this number and verify if it is correctly written here on the screen. Is this okay? Is this okay? Good. So that is minus 25. Fine. Very good. Now, I hope you are very familiar with the decimal number system. In decimal number system, if you have a number and shift decimal to the left hand side, what is that equal to? That is equal to dividing a number by 10, isn't it? For example, suppose we have a number like say 43125.6, correct? Now if I take a number, I mean, if I shift the decimal to the left hand side, what is that number equal to? That number is nothing but the same number divided by 10. So this number will be nothing but divided by 10. If I shift the decimal to the left hand side, correct? That is the situation with the decimal number system. What is the situation with the binary number system? If you shift, this is not the decimal point. So I'm sorry for writing it decimal here. In decimal number system, this point is called decimal point. In binary number system, it is called binary point. And in general, for any number system, the common name for this is the radix point. Fine. So if I shift the radix point to the left, what will that mean? That means minus 25 divided by 2. And what is that is minus 12.5. So that's what it is. So what is minus 12.5 to the base 10 is nothing but this number with the radix point shifted to one place to the left. This is the number. And if you see these two, they are exactly the same, isn't it? So that is how we can find out 2's complement of negative fractions in different possible ways. Now, you can try it. Oh, you may say, why we took it then as a division by 2? Why didn't we take division by 4? You could have tried, I mean, multiply 12.5 with 4 and then get the corresponding negative number, then shift the binary point by 2 places. In case division is by 4, we have to shift the binary point 2 places to the left. In that case as well, the answer will come out to be, or answer should come out to be exactly the same. You can try it yourself later, but I hope the logic is clear to you. Now, um, I think, who is this? One student wrote that, okay, let me check what he had written. The conversion for this minus 12.5, he had written it to be Parikshit, I think. What was it? Parikshit, had you written that? What was the number? 111 00101. No, it's not even matching with that. Okay, anyway, let us not go to the what Parikshit had said. Okay, now let us do it other way around. I mean, suppose I have given you this number in 2's complement representation. Can you find out what will be the decimal equivalent of this? Just try it, please. Try on your notebook. What will this number be? I hope I'm audible and you're on the work now or calculating. So, yes, waiting for your response. Is everyone online? Subhash, are you there? Subhash. Okay, I hope I am audible now. I'm sorry, I had lost the connection in between. Am I audible there? Okay, fine. So I had given you that calculation. Did you calculate that number? Meanwhile, what should this number be? This one, what should this be equal to in decimal? Oh, 52.5. Very good. Come on, my dear students. You still are at 12.5, Pranjal. We just now you follow your screen. 12.5 we already have written here. Is it 12.5? No, that's not, I think. Even positive 12.5 is written on your screen. And I don't think this is the same number, isn't it? Because this is 12.5 and this is not the same number. Apply some logic, right? Anshika is still, this is wrong. No, most of you didn't do it correct. It is wrong. Come on, people, apply your mind. Apply your mind. Try it again. Let me not display the answer. Try it again, everybody of you. And let me see how many of you have typed the answer. What about others? Only few have typed their answer. What about others? Sonali, I didn't see answer from you. I didn't see answer from even Diksha, I think. I didn't see answer from Dia. Even Jyoti also, I think, haven't responded to the calculation. Anshul didn't respond to the calculation. So every one of you should type your answer. It's 2's complement representation. Yes, it is 2's complement representation. So that's what I told in the beginning. I mean, what is this number in corresponding decimal form, given that it is in 2's complement representation? Yes, yes, waiting for your response. Please don't waste time. Mr. Adarsh is coming so late. Why? Let us talk to Adarsh. Meanwhile, you keep on doing your calculations. Yes, Adarsh, you are so late today. Why? I want to hear from you. Adarsh, are you online? Hello, Mr. Adarsh. Why you are so late first thing, and why you're doing all those uh, random things on your screen? Adarsh, I want to hear from you. Why you're late today? Adarsh, can you hear me? Yes, Mr. Adarsh. Patanitha means what? Don't you know what is it? Is there a class today? Very strange. Time, it is already there in the timetable, I think. Okay, anyway. Nishant, Sonali, why everybody is doing it wrong way? Sonali is wrong, Nishant is wrong. Okay, Jyoti did it correct. Jyoti Sharma, fine. I hope you have hit the right answer. So, can you please explain to others here that, okay, how did you get the answer? You can explain by simply unmuting your mic, or even if you are comfortable in typing the answer or the way it has been done. Yes, Jyoti, please. Jyoti, eventually it's wrong. It's not 11.5. There is a huge difference between plus 11.5 and minus 11.5. Isn't it? Just writing anything randomly without thinking of what you're doing. Jyoti, can you explain it to the students? Or should I do it? Jyoti, can you hear? Yes, Jyoti. Ah, anyway, I don't know where is Jyoti and she's not responding. She should. Or at least say that, okay, she is not in a position to explain, whatever. Jyoti, are you there? Can you listen us? Can you listen my voice? Or others, can you hear me? Okay, means I'm audible there. Fine. So that is all right. I mean, the answer should be 11.5 minus 11.5. Now question is how we got the answer minus 11.5. So what is the first thing you need to do? First thing is that you should note what is the most significant bit. And most significant bit, that is why I have written X here, because this bit is going for the sign of the number. So since the most significant bit is 1, so therefore the number is negative. That is why it can't be 11.5. It has to be minus 11, minus of whatever it is going to be. So now the question is how to get the remaining answer. So this is the number, and then these remaining bits, we have to take 2's complement of these bits to get the answer, correct? And what is 2's complement of these bits? That is nothing but this one, because you have to go from the say right hand side and then spot the first non-zero bit, which is this one. Up to here everything will remain same. That's what it is. I'm talking of yesterday's rule, how to get 2's complement. Then invert everything, so 0 will become 1, this 0 will become 1, this one will become 0, this 0 will become 1, and this is 0. So this is the number. And what is this number equal to? So minus already came from this bit, and what is this number is nothing but this will give you 0.5, right, after decimal. So this is 1 by 2, 2 raised to power minus 1, correct? And this will be 1 plus 2, which is 3, plus 8. So this is minus 11.5. Is this clear? Okay, fine, Jyoti, it's okay now. Is this clear to everyone? Or is there any doubt further? Okay, I assume it is clear to everyone. Fine. Now let's go to the next example. Now I give it to you. I mean, you find out what should this minus 0.25 be in 2's complement representation. What should this number be? Yes, please follow with the calculation. Let us see what you get. Now you do it yourself. Very good. Try it. I would like to see the answer from Adarsh. Are you getting something or not? I don't know. Adarsh, what is the answer to this? Do the calculation and let me know. Others, of course, will follow. Minus, arey bhai, abhi, how you are putting minus here? In binary numbers, there is nothing like plus or minus. Everything has to be written in zeros and ones. Where are you? Lost. Kanika, 0.01. Come on. I am talking about minus 0.25, not plus 0.25. So, Tanvi, I don't know if it is correct. Divyanshi is doing something. It seems okay, but still not sure. Okay, I'll be showing the answer. Let us see what others are doing. Tanvi said 1001. I don't know what logic you. We are not talking of sign magnitude representation. Fine. We are talking of 2's complement representation. 2's complement representation. Yes. Subhash, what's your answer? Anshul, what is your answer? Anshul 2. There are two Anshuls, right? I want answers from both. Shubh, what is your answer? Jyoti got it 1.11. Okay, let us see if it is correct. Uh, Adarsh, waiting for your answer. Diksha, still wrong. Shubh is saying this one. Subhash, please. Okay, Anshul. What about Anshul? Second Anshul. Okay. Many of you are doing it correct, but others still not okay. So now, okay, let us see how we can represent minus 0.125. This is one possible way to do this. You may apply some other logic also. I think I also have done it two ways here. So how we can write down minus 0.25? It is minus 1 plus 0.75. Isn't it? It is something like minus 1 plus 0.75, which will give us 0.25 minus 0.25. So I have written 1, then 0.75, both positive as of now, then 0.25. This is positive 0.25. Note it. So all of many of you have done it this way. This is just, I mean, 0.25. Then some of you have done okay 1.1.01, but that is sign magnitude representation, not 2's complement representation. So 1.01 is sign magnitude representation of it. I'm asking you to give me 2's complement representation. So how we can write down minus 0.25? It can be written this way. So how we can write down minus 1? We can write down minus 1 this way, because if this is in 2's complement, this is minus 1. Because if this is 1, what will be 1's complement of this? This will be 1 1 1 1 0. When you add 1 to this, this will be 1 1 1 1 1. Fine. Now what will be following the same logic as we did in the last example? What will this number be? Minus 0.25. This is going to be equal to this. So now it depends upon which bit size you are using, or which word size you are using, how many bits you are using for representing the number. Minus 0.25 will be 1.111, whatever. I mean 1.1. One thing which you should notice it, that after binary point there will be only two ones. Everything else should be 0. Before this, everything is going to be 1. So this is what is our minus 0.25. Is this clear to everyone? Oh, what is Divyanshi saying? Plus 1 plus 0.75. No, this is not what you are trying to say. I didn't get. Divyanshi, I want to know why 1 replaced with 0 and 0 replaced with 1 in 1's complement. Arey bhaiya, this is logic, and this is called 1's complement. I mean, that's a representation. Now why we do this? You have to understand about complements. Complement means subtracting a number from 11111. That is 1's complement. Fine. So if you subtract, you should find out the same number. You may be getting extra noise from the dogs. I'm sorry for that. This is asking something. It's up to us using. You may have a 4-bit computer, you may have a 8-bit computer, you may have a 16-bit computer. So accordingly, the number of bits we are going to use a particular number is going to depend upon what is the bit size of our machine. Fine. Okay, what else? Is there any further question? So did you get this logic of how we can get this 0.25 in 2's complement representation? I mean minus 0.25. Everyone understood what is it? How to get it? What is Divyanshi writing? Either you write down something in English or write down something in Hindi. What the hell is it? Hoga. I can't make out the meaning from these mixed things. Okay, everyone got this? What I was trying to say? How minus 0.25 is converted into 2's complement? Is it clear to everyone? Okay. Now let us do one more example. It's not over yet. You should be comfortable. Okay, this before we do the next example, one thing you should notice is that depending upon word size means number of bits in the word. So if you are using a 4 bits per word, then what is the smallest magnitude we can represent in 2's complement fraction? That is going to be 0.125, either it plus 0.125 or minus 0.125. Now in this table you should notice something interesting. Means smaller is a number, I mean after smaller is the fractional number, more is going to be the number of bits for representing that. So if you want to represent numbers more and more accurately, you have to go to the larger and larger bit size. So for a 4-bit machine, the most or the best accuracy for a number you can obtain is up to this level. If you want to represent 0. Say 0.1, that won't be, it won't be possible, because the smallest size of a number which we can represent in 4-bit case is 0.125, and 0.1 is smaller than 0.125. So that is what you should notice carefully. Similarly, when you go to a 8-bit machine, you can represent a smallest number which is of this order. Now question is, okay, how we find out this order of magnitude of a number which we can represent in a particular machine of a particular word size? So for that, let us see the example of this 0.125. Let us ask first, okay, how this minus 0.125 going to be in 2's complement representation. So okay, fine. If I try to think minus 1 plus 0.25 is equal to minus 1 plus 0.875, correct? And this 0.875 is this, and you know what is minus 1? It is this, correct? So how, for a 4-bit system, how we can write down minus 0.125 in a 2's complement representation? So we have maximum 4 bits. So this is 1, 2, 3, 4. These are 4 bits. So in 4-bit representation, minus 0.125 will be equal to 1.111. Now this is in 2's complement representation. And how to represent 0.125 in 2's complement representation? 0.125 in 2's complement representation. That will be this number going 0 and then 111. Is it so? No. that will be 0.001 because that is 1 by 8, correct? So 0.125 in 2's complement representation, positive 0.125 will be 0.001, and minus 0.125 will be 1.111. Is this clear to all? I mean, is this clear, or is there any question? Students, is this clear to all of you? Or any query from anyone? Okay. Devanshi says it's okay to her. What about others? Okay, most of you, I assume, have got the thing. Okay, let us do. Okay, so before we, I mean, I hope by now you should be comfortable with this. Let me give you some examples. I mean, oh, sorry, I didn't give you homework for this case. Okay, let me give you some homework. Note it in your notebook. Sorry, it is not in the PowerPoint presentation. You have to convert some fractions to their corresponding 2's complement notation. Fine. You write down the number. Suppose it is 8.65. 8.65, first number. So you have to actually find out plus 8.65 as well as minus 8.65. What are the two numbers in corresponding 2's complement representation? 8.65 and minus 8.65 in 2's complement representation by tomorrow. Fine. Let us do one more example. Say, suppose 18.425. Let us say this one. 18.425 and minus 18.425. So sorry, minus 18. This is a typo here. I mean, it should be minus 18.425. So you have to find out 2's complement representation of these four numbers. That is sufficient. Okay. Having done this, now we shall be understanding, or we shall be quickly discussing how to do binary arithmetic, means how to add binary numbers, then how to subtract binary numbers, how to multiply binary numbers. We will start with the simplest case of binary addition, how we can add any two binary numbers. So this we already have discussed, although in our one of the previous lectures, but this is again the same table where we can understand how two single bit binary numbers add and what will be the result. So if we add 0 to 0, it will be sum will be 0 and carry will be 0, and so on. I think this is self-explanatory, so let me not go to this as one example. So if we are adding these two numbers, so this is the first number, this is second number. How to add? If we follow this table, what will this number be? This will be 1 plus 0, that is 1. You can see from here 1 plus 0 is 1, no carry. So this is 1 plus 0 again 1, no carry again. 0 plus 1 1, again no carry, but here it is 1 plus 1, there will be 0 and 1 carry, so this is sitting here. Now how shall we verify that if it is done correct way? So let us write down corresponding decimal counterparts. The first number was actually 11 to the base 10, and second number was nothing but 12 to the base 10. And if you see the answer, now, okay, you have a carry here. So don't say, as of now, we are not saying it is in 2's complement form. Fine. So what will this number be? This number has to be 23. So we have to simply convert it. Fine. So this is 2 raised to the power 0, which is 1. This is 2. 1 plus 2, 3. This is 4. 3 plus 4, 7. 7. And this part is 8, but it is 0. So it won't contribute. It is 16. So 16 plus 7 will be 23. So simple arithmetic of simple positive numbers. So why we don't need to go to 2's complement as of now? Because we are dealing with binary addition of positive numbers only. Let us think of only positive integers for now. So that is how we can get the sum. So when we will be dealing with the mixed cases, say one number is positive, one is negative, that actually applies to the subtraction of the numbers indeed. So we will do that part also, but first let us do the simpler examples. So is this clear? Bit size, Divyanshi, bit size you can take. Okay, it is for example, so it is for your this one homework. You can follow your bit size, which is sufficient enough to represent your number accurately. So I leave it to you. You decide the bit size by yourself. I mean, minimum bits which are sufficient to represent our number accurately. That is the bit size you should use. Okay, is the bending addition clear? Okay. So how to convert that I already did for you. So it should be 23. I already showed it. Now there is another example. Suppose these are two numbers. How to add? So in this case, this is one, this is one. So the when two ones add, they gives you 1 0. So 0 1 carry. So this goes here. This is again 1 1 gives you 0 1 carry. Now here there are two ones and one additional one. So what will this be? This two will give you 0 that and one carry. So that one carry came here, and that 0 when adds to 1 will give you 1. I hope I didn't confuse you, right? So here again 1 plus 1 0 and 1 carry. To verify this, you can check this number is nothing but 10. This number is not 0. So this perfect. So far, so good. It when we had two numbers, we may have or we may add more than two numbers at once in a single go. So in that case, how to do addition? So basically, what you have to do is you have to count number of ones which have to be added. So if okay, if you have one pair for number of ones, then the outcome is going to be 0, and there has to be one carry. So if there are two pairs of number of ones, then outcome will be, I mean, if okay, if the number of ones which have to be added is uh, even, suppose it is 2 here, the output will be 0 always. So if number of ones is even, the output will be 0, and if the number of ones is odd, the output will be 1. And what about carry? So for each pair there will be one carry. So in this case there is only one pair, there is one carry somewhere. Yeah, if you see this, this is 0, this is 1. So here number of ones is 1 2 3, so output will be 1, because if number of ones is odd, output will be 1. I hope you are able to follow my words and understand the logic. So this will be 1, and for one pair there will be one carry. Here there is just even number of ones, output will be 0, and carry will be 1. Now here if you see, you have 1 2 3 4 4 ones, so output will be 0, and for each pair of ones there will be one carry. So one carry for this pair, one carry for other pair. Fine. So that is how you can continue doing things if you have to add more than one binary numbers, and then you can verify if the answer is correct. So you can convert it to corresponding decimal form and get the answer. Is this part clear? Oh, Mohit said he couldn't hear me properly. What about others? Okay, others. Did you get it properly? Yes. Okay. Most of you got it. So I request you all to please help Mohit or those who actually missed it, because we are almost running out of time for today's class. So please help them out. And well, now uh, that's what I told you. I mean, if number of ones to be added in the column is even, then some bit will be 0, and if number of ones to be added will be odd, then some bit will be 1. And how to get carry? For every pair of ones, there will be one carry going to the next column or to the next higher column. So here comes your homework. You have to add following binary numbers, and then find out what will be the answer, and also verify it with the help of corresponding decimal numbers. I mean, you have to do first with the help of binary numbers, then get the answer, and then convert all these numbers to their decimal equivalent and see if your answers are correct. Fine. And this is the second example or second set of questions which you have to do. So here are your binary decimal numbers. You have to first convert them to the binary form and then add them and find out the sum. Fine, in the binary form, and then verify your answer. One more example I have kept for you. This one is the second example. You have to convert it to binary form and then follow the rules of binary addition and get your answer. I hope that's clear for today. And in next class, we shall be actually understanding now. By now, you should, have many questions in your mind regarding two's complement representation. Why we go to that complex two's complement representation, right? So now we will be understanding the reason behind this in our next class. And we will realize that, okay, this two's complement actually is very helpful notation when we are doing binary addition. With the help of two's complement notation, we can even do subtraction as the form of addition, or we can also see the subtraction as a type of addition only in two's complement representation. So how to do that and how to understand this binary subtraction as a form of binary addition only with the help of two's complement, we shall be doing it in the next class. So fine, thank you for your attention. Hope everything was clear today. Okay, will you please show the last slide? Okay, I'm coming to the last slide. Sorry for that. So this is the last slide. You can take a screenshot of your mobile, I think. That should help you to note it very quickly. So by next class, you learn how to take screenshot in your mobile phone. That will save a lot of time. Is this clear? If it is done, just let me know. Is this done? Everybody noted it? Fine. Thank you. Thank you for your attention. I hope it was clear. Then we will meet in the next class. Till then, stay safe. Take care. Have a nice day.